Hi doctors, today we are going to discuss about dimensional formulas, how to write the dimensional formula. So in this lesson first you should come to know what is physical quantity. So what is physical quantity means any quantity which can be measured. So you came to know so many physical quantities. So time, length, kinetic energy, potential energy, force, all these will be coming under physical quantity. So, but which is going to be measured? You may don't know the definition of that, or you may know. Physical quantity means which can be measurable. Let us assume you are going to college. You are starting at 8 o'clock, and we are reaching by 8:15 there. Then how much time you have taken means 15 minutes. That 15 minutes we are going to be measured. Therefore, time is going to be physical quantity. So some physical quantities will be dividing like this. So one is fundamental physical quantity, another one is derived physical quantity. So two will be there. Those are supplementary quantities. Supplementary quantities. Here I am not writing fully FPQ I wrote fundamental physical quantity. So in that offline notes we have to write fully fundamental physical quantity. So which are fundamental physical quantities means which does not depend on any other physical quantity. So which are derived physical quantity means which depends on fundamental physical quantities. Which are depending on fundamental physical quantities, those are, we are calling it as derived physical quantities. Supplementary quantities will be there. We will call two supplementary quantities. One is solid angle, another one is plane angle. So one is radian, another one is steradian. They will be saying units for this. So one of the year they asked. So which are having units but no dimensional formula. About all those we are going to discuss. So first, which does not depend on any other physical quantity. Now I said about time. Time taken 15 minutes we said now. Therefore that 15 minutes does not depend on any other physical quantity. Therefore time is fundamental physical quantity. Like that, how many fundamental physical quantities are there for us? So these are mass. Mass is denoted by in dimensional formula capital M. So units kg, gram. I am not saying about all those. How to write the dimensional formula we will see today. Second one, length. It is denoted with capital L. So third one, time. So time is denoted with capital T. Fourth one, so temperature or current. Temperature. So in some books they will write theta, in some books they will write K. So fifth one, after temperature, electric current I am taking. In some books they will write capital A or capital I also. So sixth one, so amount of substance, that is nothing but mole. So here mass and amount of substance both are same only, but mass we are going to represent for objects which are having more mass. Gas mass will be little bit less, therefore we will take amount of substance. So seventh one, luminous intensity. This one only we are going to write it as candela. So these seven are fundamental physical quantities. These two are supplementary quantities, except the 7 and 2. Remaining all physical quantities, whatever you have known, will be coming under derived physical quantities. So we will see some derived physical quantities. So area if we are taking, volume if we are taking, area, volume I am taking, isn't it? Next, velocity if we are writing, velocity, speed, like that, whatever you can take. Area. So what is the area definition? Generally we will write means length into breadth. So for this board, what is the area means? Length into breadth. So here length and breadth will be coming under length dimension of formula, because length, breadth, height, thickness, distance, displacement, wavelength, all these will be coming under length only. So therefore, just length and breadth will be coming under L into L, therefore L square. Now to represent area A, so length is going to be raised by 2. So power of this length is 2 we got. The 2 we will call dimension. Now area dimension formula L square. Volume means generally we will write LBH. So length into breadth into height. L into L into L. Therefore L cube. In other way also you can write dimension formula. Area units meter square. Meter is the unit for length. Again we can write L square. So volume units meter cube. So again meter is the unit for length, therefore L cube. By following units also you can write, or equation also you can write. Now what is the equation or definition for velocity? Velocity is nothing but displacement by time. So what is displacement will be coming under? Displacement is also length. Therefore, L by T. Lt power minus 1. Next we will see acceleration. What is acceleration? Definition means change in velocity by time. Means velocity by time. If you forgot velocity dimension formula, then velocity can be written again displacement by time divided by time. So displacement by t square, that is nothing but L by t square, Lt power minus 2. You can follow by using units also. What are the units for acceleration? Acceleration units meter per second square. Meter is the unit for length, therefore L. Second is the unit for time, therefore t square. Like this also we can write Lt power minus 2. Now acceleration dimension formula is Lt power minus 2. Length power how much is there here? Length power is 1, time power is minus 2. So 1 is the dimension of length, minus 2 is the dimension of t. So if you want to write in terms of m, so m power 0, L t power minus 2 they will write. This is the dimension formula for acceleration. See how to write the dimension formula, you have to remember. You cannot remember always right side dimension formula. So you should remember by using the definition, you are in a position to write the dimensional formula. So now whichever we wrote here, area, volume, velocity, acceleration, all these are depending on these 7 fundamental, out of these 7 fundamental physical quantities, correct? Now can we write what is momentum? Momentum dimension formula. If you want to write dimension formula, you should come to know this equation. Product of mass and velocity. This one you will be getting in your 8th or 9th class. What is momentum definition? So product of mass and velocity means, now only I wrote mass is nothing but capital M. What is the dimension formula for velocity? I said velocity is Lt power minus 1. Correct? Lt power minus 1. Velocity dimension formula. If you forgot, just I wrote minus 2. If you forgot means like this we can take. So mass into what is velocity? Displacement by time. Therefore again you will get m L divided by t. Therefore m L t power minus 1. So finally you got m L t power minus 1 is the dimensional formula for momentum. So like this, if they are asking force, so what is the force definition? According to Newton's second law, rate of change of momentum. From this R, you are going to get ma. Everyone came to know product of mass and acceleration. So what is mass? Capital M according to physical quantities. Next, what is acceleration dimension formula? Previously I wrote Lt power minus 2. So m Lt power minus 2 is the dimension formula for force. If you remember, velocity, acceleration, force, and another one will be there, work. If you remember these 4, almost you are going to write so many dimensional formulas. You cannot remember right side dimensional formula for some physical quantities. But for these you have, if you remember means, remaining all you are going to remember automatically. So what is the work done definition? Work done is product of force and displacement. What is the force dimension formula? Now only we wrote mlt power minus 2. Displacement L. So m L square t power minus 2. If you forgot, Let us assume force dimension formula if you forgot. Then you have to write force as ma. Yes. Again acceleration also you forgot. Velocity by time. Velocity m by t. What is velocity means? Displacement by time. So now see mass, displacement, time. So if you substitute m, l divided by t. So again you are going to get same thing, you can cross check. If you forgot acceleration definition, velocity by time, force definition, force equation ma, then you no need to remember, you cannot write dimension formula for work done. So these four, if you remember, almost remaining all dimension formulas you can get without remembering those dimension formulas. Now what is work done? M L square T power minus 2. You have to recall 4 or 5 times whenever you are saying good morning, good afternoon, good night for your teachers, physics teacher especially. You can say instead of good morning, you can say ML square T power minus 2 is the work done. If you are saying Tata, bye bye, see you for your friends. So each one of you will recall formula, dimension formula, then you will remember those dimensional formulas. Now see, write the dimension formula for Newton they will ask. Write the dimension formula for Joule they will ask. Write the dimension formula for Pascal they will ask. So whenever they are asking, all these are, I think you may get idea, all these are units. Now you should come to know Newton is the dimensional, means Newton is the unit for which physical quantity, to write the dimensional formula. So Newton is the unit for force. Then what is the force dimension formula I said? I told you to remember ml t power minus 2. If you forgot means you have to write like this, ma. So m acceleration dimension formula, l t power minus 2. If you forgot acceleration also, you have to remember like this, velocity by time. Velocity is displacement by time divided by time, displacement by t into t square. So like this you have to remember, isn't it? If you forgot velocity definition, displacement by time, if you forgot this, let us assume, then you no need to remember for acceleration also, because so for this you have to remember like this, you have to follow. So acceleration, if you call 2 to 3 times, definitely everyone can remember L T power minus 2. So force is ml T power minus 2. Therefore, dimension formula for Newton also ml T power minus 2. Now Joule, you should come to know Joule is the unit for which physical quantity. If you don't know which physical quantity unit is for this one, means you cannot write the dimension formula. Very simple. Now Joule is the unit of which one? Either work or energy. Therefore, what is the work done dimension formula? Now only we wrote ml square T power minus 2. So this is the dimension formula for work done. Next, Pascal. Now what is the physical quantity? So which physical quantity unit is Pascal? So Pascal is the unit for which one? Pressure. Correct? So you should come to know this. Now pressure dimension formula we didn't write, but pressure equation you should come to know. Force per unit area, F by A. Again, force ml T power minus 2 divided by area we wrote already. Area is nothing but length into breadth, therefore L square. So 1 L will be cancelled. If you cancel 1 L, so m L power minus 1 T power minus 2. This is going to be pressure. Pressure dimension formula according to unit we wrote. Like this, whichever unit they are giving, for that unit, if you are able to write the dimension formula, so you should come to know the physical quantity. Let us assume Newton meter. Newton meter is the unit. Now, what is the dimension formula for Newton meter? So, Newton is unit for force. Therefore, ml T power minus 2. Meter is unit for length. Therefore, L we wrote. So, finally, you got ml square T power minus 2. See, ml square T power minus 2 already it is for work done. So, Joule another unit, Newton meter also we can follow. and this is torque definition you will get. Torque is force into perpendicular distance. For torque also you are going to get same dimensional formula, isn't it? So like this, from the units also we are able to write the dimensional formula. Now you can recall once whichever physical quantities you came to know, whichever physical quantity you came to know. If you know that equation, definitely you people can write the dimensional formula. So universal gravitational constant, capital G. So you should come to know where capital G will be coming. So you should get idea of all the relations where capital G is there. So everyone came to know F is equal to G m1 m2 by r square. Otherwise, you people came to know G is equal to Gm by r square, isn't it? Otherwise, time period of simple pendulum 2 pi root L by G. Otherwise, units of this capital G. Sorry, in this no capital G is there, only small g. Again, small g will be writing Gm by r square. So, like this, wherever capital G is coming, you have to cross check. Now, see how to write the dimension formula for capital G. So, capital G is equal to, you can send this side, F r square by m1 m2. Now, you can write one by one dimension formula. What is the force dimension formula? M L T power minus 2. What is the distance? R is nothing but distance between two masses, m1, m2 distance. Therefore, what is distance dimension formula we said? L, fundamental physical quantities. Mass, m into m. So, one m will be cancelled. If m is going for numerator, m power minus 1, L into L square, L cube, T power minus 2. Some people may remember, some people may forget this, but if you remember this equation or this equation, you can get same formula. Now see this one here. So to write capital G, G r square by capital M. M is mass of the planet, R is radius of the planet, small g is, what is small g here? Acceleration due to gravity. This is also acceleration. Therefore, what is acceleration dimension formula? Lt power minus 2. R is nothing but radius. Radius will be coming under length. Therefore, L square divided by mass. Now you can see, again you are going to get same, m power minus 1, L into L square, L cube, T power minus 2. So, like this, if you know the equation, definitely we are going to write the dimensional formula, isn't it? So, you should remember like this, not by hearting right side dimensional formulas. You cannot by heart. If you by heart also, in place of minus 1, you will take 1, in place of 3, you will write 2, like that. Therefore, if you remember like this, you cannot write wrong dimensional formula. Next, Planck's constant. So, Planck's constant. So, what is the dimension formula of Planck's constant if they asked? So, for that equation you should come to know. Everyone came to know E is equal to h mu. So, what is mu here means frequency. E means here energy, isn't it? So, then h is equal to E by mu. Now, you should come to know energy dimension formula, frequency dimensional formula. So, for energy, all energies we are going to get from work done, kinetic energy, potential energy, all this. Therefore, work done and energy dimension formulas are same. You came to know potential energy very well. U is equal to mgh. What is m? Mass. G, acceleration due to gravity. L t power minus 2. H is L. Therefore, m L square t power minus 2. See, potential energy you got, work done, m L square t power minus 2. If you wrote kinetic energy formula of mv square, of is constant, m, what is velocity dimension formula? Lt power minus 1 whole square, m L square t power minus 2. So, this is the equation for kinetic energy. Therefore, energy dimension formula is m L square t power minus 2. Now, what is the dimension formula for frequency? Again, you should come to know frequency units or equation. What is the frequency equation means? Reciprocal of time period or second inverse or hedges. So, reciprocal of time period means, again this is time, 1 by t, t power minus 1. Substitute here t power minus 1. If it is going to numerator, m L square t power minus 2 t power plus 1. So m L square t power minus 1. So this is the dimension formula for Planck's constant. So you cannot remember ml square t power minus 1, but you can remember E is equal to h mu. So to write each and every dimensional formula, what you people should come to know means, you people should come to know the either equation or unit. This equation if you know also you can write, if you know the unit also you people can write. You cannot by heart dimensional formula, you can remember how to write the dimensional formula. Then how the questions will be coming in competitive. Sometimes they may ask directly dimension formula, but sometimes how the questions will be coming by knowing this dimension formula, we will see in next class. But now we will see one more dimensional formula. Now see what is the dimension formula for watt. So watts or watt is the unit for power. So what is the power definition? So first you should come to know this is unit for which physical quantity. Otherwise you cannot write dimensional formula. Even though if you know how to write the dimensional formula, you cannot write because you don't know. If you don't know, power unit is going to be watt. So power unit watt. Therefore power definition, work by time or rate of doing work. Again work done dimensional formula, ml square t power minus 2 divided by t. So m L square t power minus 2 t power minus 1. So m L square t power minus. This is the dimension formula for power. So remembering this one is difficult, m L square t power minus 3. But remembering power formula. So another equation also will be there for power. So who have completed this lesson, work energy power, they came to know force into velocity. So what is the dimension formula for force? ml t power minus 2. What is the dimension formula for velocity? L t power minus 1. Again you can multiply m L into L square t power minus 2 minus 1 minus 3. So this is the dimension formula for power. So in second year you are going to get charge. What is the dimension formula for charge? So charge is nothing but it will be coming under, it is derived physical quantity. Current I is equal to Q by T. Charge per unit time. Then charge is IT. I is fundamental physical quantity. Current, time is fundamental physical quantity. So therefore charge dimension formula is AT. In second year, who are in second year? So they should come to know charge dimension formula. Once you came to know charge, you can get so many dimensional formulas. Electric field intensity, E is equal to F by Q or Q naught. So F dimension formula, m L t power minus 2, charge dimension formula. Now only we wrote. Therefore final equation you will get m L t power minus 2 t power minus 1 a power minus 1. So m L t power minus 3 a power minus 1. This is the dimension formula for electric field. So right side dimension formula you cannot remember, but you people can remember E is equal to F by Q very well. Otherwise E is equal to kq by r square. Whichever equation you came to know, however you are going to get. So Newton per coulomb. Unit is Newton per coulomb. Now I am asking what is the dimension formula for volt? What is the dimension formula for volt? So voltage. Now you should come to know volt is the unit for which physical quantity? Potential. What is potential equation? Work done per unit charge, test charge, W by Q. So volt is nothing but voltage definition or potential definition, electric potential definition, W by Q naught. What is W here means work done. Now what is work done dimension formula? M L square t power minus 2. What is charge dimension formula? AT. So if you rearrange this, so m L square t power minus 2 t power minus 1 a power minus 1. So m L square t power minus 3 a power minus 1. This is the dimension formula for voltage or dimension formula for volt or electric potential. So like this we are going to remember all those just by remembering the equation, not by remembering the dimensional formula. You cannot remember always right side physical quantities. By using this you are going to write the dimension formula very easily. So practice, so many physical quantities are there. So unlimited physical quantities are there for you in physics. So it will be, there is no end for these dimensional formulas. You can write so many, but here how they are going to ask in competitive, that is our main agenda. For that, first we should come to know dimension formula, how to write. Once after knowing this, how they are going to ask the problems in NEET exam, we are going to see in our next class. So try to practice some dimension formulas except these what we have written. Let us assume I am saying about one example. By next video you have to write, otherwise I am going to give. So write the dimension formula for poise. So poise is the unit for which physical quantity you people should come to know. So in next video we are going to see what is the, how to write the dimension formula. Otherwise you can set once poise where it is going to come, then you are going to get. Otherwise you know how to write the dimension formula because you don't know which unit is for this physical quantity. Watt is the unit for power, joule is the unit for energy, Newton is the unit for force. Now poise is the unit for. If you know, you can write, otherwise we cannot solve the problem. Okay, we will see in next video remaining dimension formulas and how they will ask problems in your NEET exam. Thank you.